1, liftoff.
So far we've looked at bonding between polar molecules, but in substances such as the hydrogen and oxygen used to power rockets, the covalent bonds are not polar. In a hydrogen molecule, the atoms share their electrons to form a covalent bond. The two atoms, of course, have the same electronegativity. This means that the electrons are shared evenly and not pulled towards either end of the bond. The molecule is not a dipole, so there are no dipole-dipole interactions to hold the molecules together. Not surprisingly, hydrogen exists as a gas at normal temperatures, its molecules moving independently of each other. Yet if the temperature is lowered far enough, the gas condenses to a liquid. This means that some kind of bonding is operating between the molecules. But what? We need to look again at the electrons. Although their speed varies, electrons are always in motion. They move at random within the bond region, like two blowflies in a jar. So there must be certain moments when they're both at one end of the region. For that instant, they turn the molecule into a dipole. One side has a slight negative charge, the other positive. Extraordinary as it seems, this is enough to induce a momentary polarity in a neighbouring molecule. The negative side of the first molecule repels the electrons of the next, so its near side becomes slightly positive and its far side slightly negative. A chain reaction is set off, each molecule inducing the same polarity in the next. Although short-lived, the weak attractive forces between the molecules are enough to hold them together if they're moving slowly enough. Known as dispersion forces, they explain how molecules which are essentially non-polar can form bonds with each other. You may sometimes hear dispersion forces described as van der Waals forces, because the first person to suggest that they existed was the Dutch scientist Johannes van der Waals.